Okay, g'day guys. So today we're going to be continuing our study of inland waters, and in particular looking at what happens when we as humans divert water from inland rivers and lakes, and in particular look at a case study of a dying lake, Lake Urmia in Iran. So what happens when we divert water? Many of the world's greatest lakes are shrinking, and large rivers such as the Colorado, Rio Grande, Indus, Ganges, Nile, and Murray rivers discharge very little water into the sea for months and even years at a time. Up to 1/3 of the world's major rivers and lakes are drying up, and the groundwater wells for 3 billion people are being affected. The overuse and diversion of water is largely to blame. Now let's have a look at what is groundwater to have an understanding of what we mean by the groundwater wells for 3 billion people. Let's have a look at what groundwater is. Groundwater is one of the invisible parts of the water cycle as it lies beneath our feet. Rainwater that does not run off the surface or fill rivers, lakes and oceans will gradually seep into the ground. So this image on the right shows this groundwater process really well. Okay, so I've got precipitation, which is rain, part of our water cycle. And for instance, if it's the top of a hill, we'll have surface runoff. So water that doesn't get absorbed will run down the hill, maybe get absorbed by the trees and remain in the soil. And then if there's more water, run down the hill into this lake here, or a river, or a stream. Naturally, it's going to follow the force of gravity. Now, if there's so much water that it can actually get absorbed into the ground. Now, this isn't a new term for you, or process. We've looked at it before. That water goes deeper and deeper, and eventually it's what we call groundwater. And we know that that's one way of storing water effectively because there's a reduced rate of evaporation. So that's where the groundwater can be stored. So water is able to move through these aquifers. So it's stored in porous rock layers called aquifers, and water can be stored in these for thousands of years. Unlike most other natural resources, groundwater is found everywhere throughout the world. Again, because there's that reduced rate of evaporation, it can just stay in the ground. Why is water being diverted? So when we think, we need to understand what we mean by diversion. So when we mean by diversion of water, it's a man-made project to divert the water from a river for a particular reason, of course, otherwise it wouldn't be done. So due to the uneven distribution of water and population, there is often the need to transfer water, and large-scale diversions often require piping or plumbing water from one drainage basin to another. For example, water from the Snowy River is diverted into the Murray and Murrumbidgee rivers. So diverting water can do two things: alleviate water shortages, and it allows for the development of irrigation and the production of hydroelectricity. So there are our two main reasons why water is being diverted, and a lot of the time it's to alleviate water shortages in another area. But again, as more and more dams are being built, and the water is going to be diverted for reasons such as the hydroelectricity production. However, diversions are not always the most suitable use of water resources. Now, as I mentioned at the start, we're looking at Lake Urmia in Iran. This is the largest lake in the Middle East and one of the largest salt lakes in the world, and it's drying up. Since 2005, Lake Urmia in northern Iran has lost more than 65% of its surface area, exposing extensive areas of salt flats. Now, these two images compare the Lake Urmia. This aerial shot taken in 1998 and this one taken in 2011. We can just see the difference, the colour in the water, the salt that's being exposed. So since 2005, that's only 10 years ago, it's lost more than 65% of its surface area. Now this was taken in 1998, so that just shows the massive impact that we as humans are having on this lake. The lake was declared a wetland of international importance by the Ramsar Convention in 1971, and a UNESCO, which is the United Nations Educational, Scientific and Cultural Organization, Biosphere Reserve in 1976. The lake and its surrounding wetlands serve as a seasonal habitat and feeding ground for migratory birds that feed on the lake's shrimp. Shrimp is the only thing other than plankton that can live in the salty water. Lake Ermia is a terminal lake. Rivers, some permanent and some ephemeral, that flow into the lake bring naturally occurring salts. So terminal lake, a lake where the water does not drain into a river or sea. Water can leave only through evaporation, which can increase salt levels in arid regions. Because of the arid climate, high evaporation causes salt crystals to build up around the shoreline. Figure 2 shows the decline in surface area of Lake Ermia. So this is Figure 2. We can see that from 1998, there's been a consistent decline in the area in square kilometres of this lake. From 1963, it's been fairly consistent around the 4,500 square kilometre mark, peaking around 5,600, and now we're looking at just over 2,000 square kilometres. So that is still huge. So when we look at this map, these aerial photos, we need to take into the scale of this lake. It's at the moment still over 2,000 square kilometres, which is a vast size. So why is the lake drying up? Mainly we've got 3 reasons. And it's a combination of prolonged drought and increased diversions for irrigation. Often people withdraw water illegally without paying for it, or take more than they are allocated. So people might take it for irrigation reasons, they need it to grow their crops, or if there's some clean areas of the lake, they might filter it and use it for drinking. So our 3 reasons, looking at our pie chart here, 10%, obviously there's a decrease in rainfall over the lake. Now that's a naturally occurring process that we don't have much control over. 25%, construction of dams in the catchment areas. So upstream catchments that would naturally flow into the lake, dams would be constructed there and taking away 25% of the water that would naturally come through the flowing of those rivers. That's a large proportion. 65%, decrease in water inflows, drought and diversions for irrigation upstream. Okay, so drought and diversions for irrigation upstream. So man-made diversions to take water somewhere else. The average rainfall is 235 millimeters. The last decade has seen this decrease by 40 millimeters. So this is Lake 3, Figure 3. So some impacts on the lake. Increased salinity of the lake due to high evaporation and reduced fresh water. Collapse of the lake's ecosystem and food chain. Loss of habitat as surrounding wetlands dry up, which then reduces tourism to view wetland wildlife, which we know can be one of the positives out of natural rivers, and even dams can be an increase in tourism, only one of the several or limited positives. Over 400 square kilometres of exposed lake bed around its shores is nothing but salty deserts, unable to support native vegetation or food crops. Salt storms occur as wind blows salt and dust from the exposed dry lake bed, which is a potential health hazard for people. And water is less water is available for food production. So there impacts that diversions and the impacts the construction that we've been doing as humans have on this lake. What are some possible actions? Essentially, more water is required to flow into these lakes. So we've seen that construction of dams is taking away 25%, and 65% is being used for irrigation upstreams and diversions. This water must come from either reducing water allocated to irrigation and or transferring water into the basin from the Zab or Aras rivers, or even the Caspian Sea, over 300 kilometers away. This would require cooperation of other countries, and the scale of the project would be huge. But would that be enough to save the lake? This is Figure 4. distribution of dams existing and under construction in the lake's catchment area. This level of diversions is unstable. So looking at our map, and our legend here is the key to understand this. Red dots are dams that are under construction, under study. So they are probably being assessed whether it's suitable for a dam to be put up. Our yellow or orange dots are dams that are under construction, and our green dots are dams that are actually in operation. So if those dams under construction when they get finished, and dams under study, if they go ahead and get built, that's just going to have a more of a negative impact on Lake Urmia. That's the content for today. We're going to be looking at the tasks from the worksheet that I handed you last lesson.